Hi, my name is Jacob Breon, and this is my final project for MIS 670. So I started off with Business and Data Understanding. My goal is to analyze the public opinion of the Ford Fusion and cars in general. I'll look at articles as well as tweets to find out if the car is popular among the general public and what its positives and negatives are. I will then use this data and information that I've collected in order to recommend this car or other types of cars if they happen to be better to the American population. So I started off with data identification and collection. I've imported my packages. So I started off with web crawling. So I went to this autoblog.com to find Ford Fusion reviews. I was able to web crawl it, and here are the titles. Next thing I moved on to was Twitter API. So I imported the packages, was able to create a data file in Spider, and then I brought it over here to Jupyter Notebook. So this is what I've been using. Here's some of it. I'll scroll through it. All right. So now see how many tweets I ended up getting. 312. Just removing some of the save error messages, saving screen names. It all stays at the same number of tweets, so that's good. All right, so now what I'm doing is extracting information into a CSV file and creating a data frame. So this DF1 is the reviews from autoblog.com. This DF2 are the tweets that I used for Twitter with Twitter API. So next I went through and cleaned both DF1 and DF2, got it to just the title, got it to the specific columns that I wanted. I then took that text file and I took the text file from the tweets, the text column, and moved it to a CSV file. Now we're doing descriptive analytics. So I opened up that CSV file that I created with the previous text column. I've removed some stop words, and now I'm going to do frequency analysis. So the most common word was obviously cars. A few ones to notice are like at 23 and good, 19, top. These are all positive adjectives that I'll kind of discuss more when I get to my conclusion and storytelling. So I did bigrams this time, see which common phrases came together. And then I created a word cloud with the most common words. Now let's move on to content analytics and specifically text classification. All right, so what I'm doing here is doing some cleaning within the text column to kind of make it to the standards that I wanted. I'm removing a lot of the junk that we don't really need and getting it basically to just the text so I can analyze it further. All right, and then I removed some stop words from that. I moved it over to this title column now. All right, now I'm creating, then I pulled that specific title column which is the clean text column into a new data frame. Now what I'm doing is creating that label column so I can append the reviews along with the texts or the tweets into one data frame, which is what I did right here. All right, now I'm kind of just doing a little bit more cleaning in order to make sure everything's all right. And now we're going down, and I actually exported it to a CSV file. So we then can open it and do vectorization, and I'll keep scrolling through. Some of the feature names. Here's the FTIF matrix. All right, now we started split validation. So I've done the X train X test, Y train Y test. Now I moved on to support vector machine. So this is to judge the accuracy of determining which are tweets and which are the reviews. So it was able to produce the support vector machine was able to produce a 98.4% accuracy, which is very good. And I actually tried a couple others, K-neighbors, but and that one was just not as good. So I decided to go with support vector machine because it was had the highest accuracy out of all of them. So now I moved on to sentiment analysis. And this is analyzing the tweets in order and separating them into positive and negative based on the intensity. So it judges the sentiment of each tweet and rates it a score from -1 to 1. Anything above 0 is positive, anything below 0 is negative, and you can see we found 149 positive reviews, 61 negative reviews, and 102 neutral ones. And here are the top 5 tweets in terms of positive, and here is the negative tweets. Here's kind of a distribution. As you can see, there's a lot right around 0, but there's a significant amount more above 0 than what is below 0. All right, so then I moved on to network analytics, and this is kind of what I've done to clean the original CSV file in order to get it so mentions is by itself. So as you can see right here, I've created a screen name data frame with just 2 columns, screen name and mentions, and then I transported it to a CSV file so then I could use it in Jiffy to create these different node level metrics visuals. So the size is based on degree, as you can see, USA Today, Rotten in Denmark, David Hondeven. Those are some of the highest degrees, and then color is based on eigenvector centrality. So then I moved on to network level metrics and clustering. And as you can see, again, USA Today, Rotten in Denmark, they are some of the biggest and have the most individual data points in their clusters. It's pretty all spread out though. So now I've moved on. Oh, and again, color is based on modularity class. So let's move on to storytelling and my conclusion. So cars are used every day in the US by millions of people, and it was my goal to find out if the Ford Fusion was a popular and safe car according to various car reviews along with tweets. I then tested the reviews and tweets using different analyses, frequency analysis, text classification, sentiment analysis, and network analysis using Jiffy. So after removing some of the most common words like Ford and Fusion and frequency analysis, the positive adjectives like and good were some of the most common words associated with tweets that I analyzed. And this shows that the car is well received by the general population on Twitter. I then used the support vector machine for classification and regression analysis of the reviews I had gotten through web crawling versus the tweets that I had gotten through Twitter API. SVM came back with an accuracy of 98.4%. That means that the reviews and tweets provide different information, but it's all relevant to what I'm trying to find. So then I use sentiment analysis to determine the intensity of each tweet, and each tweet was then given a positive intensity if it was deemed positive, and a negative intensity if it was deemed to be a negative tweet. And that was 149 positive, 61 negative ones, which shows that, again, there's an overwhelming response to Ford Fusion being a positive and great car for personally drive. Then I use Jiffy to do network analysis. I use the mentions in the tweet and match them up to the screen names, like I showed you earlier. Then I perform node and network level metrics to determine the relationships between the mentions and screen names. The most common mention was USA Today. Then I used the YIF and WHO layout for network metrics that showed the clustering of all the mentions in the tweets. So overall, my analysis leads to believe me that Ford Fusion is a great car for the American population, and I personally own a Ford Fusion and will continue to purchase them as they are very reliable, easy to fix, and drive well.